Hi, everyone. How's everyone doing today?
Good morning. Good morning.
Morning, everyone. So just gonna give it a bit wait about a minute before everyone comes in, and then we'll start the presentation. Okay, we have around 19. Okay, I think we have enough so far to start the presentation. So I just want to say, everyone, thank you for coming in today for our webinar. My name is Prasant, and I'll be hosting your session for today. Just for some background, I have experience in the consulting industry for about 4 years now. And for our presenters today, we have Adam and Dragos, who'll be going over in detail of the role of energy efficiency in buildings for 2025 and beyond, supporting decarbonization efforts. So before we get started, just want to remind everyone that we're going to be muting everyone for now, just to avoid any background noise. But we do encourage it for you to have discussions. So please raise your hand or turn on your camera and mic, and then or you can leave a chat message in the chat. With that being said, I'll pass it over to Adam and Dragos to start the presentation.
Thank you, Birasant. Hi, everyone. I have a pleasure, together with Adam, to present to you a few of our ideas related to energy efficiency in buildings and where we think the industry will go in the direction, including decarbonization.
Yep. So, good morning, everybody. I'm Adam Dixon. Yeah, I've been in the energy industry kind of somewhat my entire life, and so some of you may have come across some of my father's presentations. So I work with him. So I've been absorbing things over the years to be able to provide some insight into maybe where the industry is going in the next few years. So, welcome.
Great, great. So the agenda for today, we'll start with introducing the concept of energy efficiency, how this relates to decarbonization. Then we'll go over a few of the more mainstream energy efficiency measures, projects that were implemented and tested, confirmed that these measures give us the results we want. But we also want to cover some of the emergent technologies and where the industry is moving on to the next phase. And as Pirasan mentioned, we encourage exchange of ideas and interaction because networking is one of the main elements that we hope to benefit in the industry. So this session is meant to cover these three objectives. We want to understand energy efficiency and relationship with decarbonization efforts in the built environment. We'll look at technology strategies related to the industry, the building sector in Ontario. There are some incentives, grants, supports that we can get for our projects. And then we'll see how energy efficiency contributes to the decarbonization targets in the industry, both with the traditional, conventional type of measures as well as new innovative technologies. So to start our presentation, we just want to kind of do a refresher of the concept of energy efficiency. By definition, what we understand by energy efficiency is basically providing a certain service with using less energy, but not at the expense of providing less service. So we want same or better comfort, same or better performance for our built environment, but using less energy. How we do this? Well, we try to optimize our systems in the buildings. We use different technologies and processes that focus on reducing basically the energy that's not providing any service. We call that the waste. We look at reducing cost for our building is not just the energy, but also additional benefits for the built environment through maintenance and operational cost. And not least important, reducing the impact on the environment. So with keeping this concept of energy efficiency in mind, we are going to go through the 4 topics we want to cover in today's presentation. But we don't have time to go through introducing every participant in the call. What we'd like to do, though, is to use a poll to kind of place this group within the energy management focus on energy efficiency perspective. So we set up a poll, and hopefully, responses that the group will give to this poll will help us better gear the discussion for the next almost 1 hour left. So, Pierre-Sant, can you share the screen, and let's give the link to the poll to everyone?
Yeah. Is everyone able to see the poll right now? Yeah. Getting some thumbs up right now. Okay. So the first question is going to be, tell us about your role in energy efficiency. So all the answers are anonymous. So just feel free to spout out your answers. Your project management, design, consultant, optimization, program coordinators, IC monitoring, smart buildings. Okay. We have a wide range of roles in the energy efficiency industry right now. Okay.
That's great. That's great.
Yeah, that's good. That's good.
It looks like not everybody got the poll number, the link. Is it something that you can share quickly, Pierre-Sant, or should I go back to the slide?
I think if you go back to the slide, but everyone should have access to the app. But if you go back to the slide,
I'll grab the link. No need to change.
Okay. Thank you, Megan. We'll just wait about a minute then until everyone has access.
Yeah, and as we see more of these inputs coming in, just let me tell you a story. Stephen, that Adam referred to, and myself, we've been in this industry forever. And when we started here, if I were to do the same poll, technology wasn't there by then. But if we were to do this at the same time, I would have said that the majority of responses would be in the consulting world. So when I started working in this industry, everybody working in energy management, energy efficiency was mostly in the consulting world. But the trend over the last 10, 15 years is that we get a lot more contributions to energy management, energy efficiency from building owners, building facility managers, authorities that have jurisdiction in certain programs. So you see the field in the built environment being now kind of balanced. It's no longer just consultants. It's a combination of building facilities teams, as well as authorities that have jurisdiction.
Okay, thank you for that, Dragos. I think we'll move on to the next question now. Just on the time.
Perfect. So I'll get control back of the slides, Pierre-Sant.
Yeah. We have one more question, and then.
Oh, sorry.
Yeah.
My apologies. I arrived. Can you go back?
Yeah.
Same link, I guess, for the same poll.
Yeah, so it's the same link again, and everyone should have access to this next one right here. So the next question is, where are you in your energy management framework? So you have one of 4 options to pick. It's you haven't started yet, you're in the development phase, implementation phase, or you're just constantly improving right now. So again, feel free to respond. All your answers are anonymous. So far we have majority is continuous improvement, which is really good to hear, actually.
It's excellent. Yes, it's excellent. That means that, the culture of energy management started quite a while ago in your organizations there. And it's the trend, the chart that we would like to see in this industry, moving towards the right side of this chart.
Exactly. Yeah, 4 for not started, 7 for development, 8 for implementation, and 15 for continuous improvement. Then give it about just another 25-30 seconds before we move on to the rest of the presentation. So again, as the presentations, as we go forward the presentation, feel free to message in the chat or just raise your hand for any questions and discussions. Okay, it seems like we're kind of stagnating the answers now, so we'll proceed forward in presentation.
So yes, I'll get back to the slides, and definitely based on what we see on this chart summarizing the responses, we do expect some interaction, because we want to hear from you folks as well, as you are experienced in this field of energy management. Let me get back to the slides. So in the framework of implementing energy conservation projects, energy efficiency improvements, we try to follow somehow the process highlighted in this slide here. So the starting point in this process is basically identifying the inputs of energy in our facilities. And to understand how energy is used in our facilities, we'll consider any energy conversion equipment that we may see in our building systems: boilers, chillers, any conversion of energy to a useful form of energy will be accounted for. And finally, we will try to understand the end use. So basically, we get a flow of energy from the input, your utility meter, all the way to the end use of energy, which is the service that we want from the energy: lighting, heating in our buildings, dehumidification, filtration, whatever we need energy for. But in this process here, there is a lot of opportunity for improving how we use energy in our buildings, reducing the amount of energy that we supply in our building without reducing the level of service. And, interesting enough, the most effective way to address this is in a reverse order. So basically, we start from identifying what type of energy use is not required. So we basically minimize the use, not by minimize the service, but by reducing the waste. So that's the least cost type of measure that we want to implement, the most effective, and it relies a lot on stakeholders involved in how the energy is used: building occupants, facilities managers, building operators. So this is the first step, once again, because economically is the most effective one. Then we can also look at improving the efficiency of any of those energy conversion systems we have in our building. For example, we can install higher efficiency boilers. We can improve the chilled water plant efficiency by optimizing how cooling towers and pumps and chillers work. Or we can use heat pumps. That's a technology that's very in fashion nowadays. And when we improve this efficiency to the point, close to where technologically is possible, then we can look at renewable energy. So basically optimizing the supply of energy by offsetting some of the energy we purchase from local distribution companies with renewable energy. In the words of one of my colleagues from the City of Toronto from many years ago, what we want to do is conservation before generation. So we want to identify first any type of waste before we actually generate new energy here. So we hope that this is, now established in the industry. We kind of go through this process in this order. And when we identify various opportunities in the bottom part of this chart, reducing waste, improving equipment efficiency, or identifying opportunities for renewable energy, we can then look at how these measures can help our organizations move on towards decarbonization. And if you are familiar with a tool that is really popular in the industry, RedScreen, the software that we use for energy management in various type of projects, we can develop a diagram like the one presented in this slide here. This is an example for a certain project that's used as a test case in RedScreen software, we can develop a waterfall diagram, which tells us that, identifying the baseline, which is the current situation, and this water flow is for the emissions associated with using energy in our facilities. So that will be emissions mostly related to scope 1 and 2. This is what building systems will address first. We can identify various steps in the process of decarbonization. And in this case, we identify quite a large potential of reducing emissions associated with energy efficiency measures in the building. But beyond that, if we are aiming for a target of net zero, which quite a lot of organizations now plan for, we need to look at additional measures. And what we show in this chart here is that, you have to complement energy efficiency with, let's say, fuel switch, heat pumps, electrification for heating, using on-site renewables, maybe off-site renewables, and lastly, maybe looking at some carbon offsets for the last bit of emissions that you need to reduce in order to achieve the net zero. So this tool, this water flow diagram, is really an important step in the planning process, because we can jump all the way to net zero by adding, let's say, on-site or off-site renewables. That will be extremely expensive, so to a point uneconomically. So now we're going to focus today on this big item here, how to achieve energy efficiency. And the first set of measures will focus on conventional, basically solutions that were tested, proven in the industry. And the first one that we want to start would be behavioral change. Once again, I kind of date myself, but when I started working in this industry, once again, consultants were the majority of the contributors to energy management, energy efficiency in projects. And we, at that time, saw very little collaboration between various stakeholders. Today, in today's environment, this is impossible. And what we see in this chart here is that just by having awareness in our stakeholders, building occupants, facilities management, we can achieve miraculously a significant amount of energy. In this chart showing about 8%. So there are some studies done that show that just by being aware of how you use energy and where you use energy, you can reduce that by somewhere between 5 and 8%, very easy. This shows here about 8%. So how do we do this? Well, we now have support in developing an awareness campaign, an awareness plan for our organization. So basically, most organizations will have a team dedicated to energy management. It is part of facilities most of the time. But what we want to do is to expand this impact beyond just the membership of that team. So we want to develop key messages that will reach out to all stakeholders, select the proper communication tools. We want to include energy efficiency, energy management in various activities and events organized by our firm, by our company. And then definitely we want to share success stories and progress updates that recognize contributions to this team that will hopefully enhance participation in the future. Now, I see behavior change as being, low-cost type of measure. It does impact on the success of many of the other more technical, more capital-intensive measures, because it does require buy-in from various other stakeholders in the organization. So it's important to keep this in mind, and it can account for up to 8% of savings. But going back to the chart I showed before, I see identifying and reducing the waste, possibly eliminating the waste, as being the first step in implementing energy efficiency, because it's also the step that will give us results at fairly low cost and short timelines typically. So what we are looking for here is, can we conserve energy, meaning we want to use energy only when we need it, so by avoiding that type of service that's not required. And you see a few examples here. We can control lights off in unoccupied areas. We can use programmable thermostats. Same idea. Unoccupied areas need less a level of comfort than occupied areas. Very popular now because of the plug loads and electronic loads in our buildings. We have smart solutions that can reduce those phantom loads. Various technologies out there, from your smart extension cord to smart plugs that will connect into a building automation system. Powering off unused appliances, that's another method of avoiding this waste. Again, we don't need those printers to be on all night long, since nobody will be there to use them. And finally, optimizing loads for equipment cycles. That's something that we can control in scheduling how we start air handling units in the morning in our building, how we schedule those optimum start stop in our buildings. So those are elements that eliminate the waste without changing any of the level of comfort for the occupants. But from here on, I would look at building systems that allow us to improve energy efficiency. And the first one to consider here is the building envelope. It's not a very exciting field, but from many, many years ago, 30, 40 years ago, Canada has a lot of experience in building efficient building envelopes for our buildings. Due to our climate, we have to be aware of heat flows. In the winter, we get high delta T, the temperature differential between conditioned spaces and outdoors, and there's nothing we can do here. Heat will flow from high temperature to low temperature, so we need to be aware of how energy flows in a building envelope, so that we can try to reduce those heat flows. And what we see here in this chart is visualizing the various heat loads, heat gains, heat losses for our building envelopes that we need to be aware of, and which elements are more sensitive to heat loss, heat gain. Transparent components, windows. Typically in any type of building, the best window is usually less performant than the worst opaque wall component that you will see in your building. So we have to be aware of that. And sometimes we can use this to our advantage. For example, using passive heating, a window will let more energy in many days of the winter than will let energy out. So we have to be aware of that and use it to our advantage.
Sorry, Dragos, I think we have a question raised here.
Perfect.
Yep, David, go ahead.
I just want to build on what you said, because initially, windows were considered, there's no payback. Well, we've seen now, including in RETScreen, that lets us model. It's also the air leakage around windows and the thermal bridging. And I think as I mentioned, I've been studying these options for many years, because I think in terms of decarbonization, it's one of the important steps, and it'll downsize whatever heat pumps we do. So I just want to Thanks.
Yeah, perfect. Thank you, David. That's true. So what we want first, and I'll get to HVAC system later, is to reduce those loads before we do those conversions later. So building envelope should be investigated, and there are various technologies nowadays that will allow us to improve performance, as David mentioned, for example, high performance windows. So moving on to the next big category of systems we see in our buildings, lighting retrofits. I think by now everyone is very, very comfortable with the idea of LED lighting, which is significantly more efficient in our buildings. But what we need to also understand that for that useful light that we get in our space, there is a lot of waste that we see here in this process of converting electricity. So we still have a lot of improvements, potential improvements in this field here that we hope to see implemented in our buildings. And it's beyond just the LED technologies, the design of the fixtures, the colors of our walls. So there is, using daylight integrated into our building lighting design system. And very important to not now discount lighting measures because, we all have an LED fixture in our space, but look at opportunities how to make that more efficient. So once again, proven technology. We've seen it successfully implemented over the last 10, 15 years in many buildings. And I'm heading out to the most complex system and energy conservation measures that we can design for our system, which are related to the HVAC systems. We still see a lot of opportunity here. And what I try to do on these slides is kind of summarize the type of energy transfers, energy flows in our buildings. We aim to provide comfortable conditions to our occupants. And this is basically using equipment that produces heat or cools or dehumidifies or humidifies the air. And then we have distribution systems to send this energy into the conditioned space. We use various type of equipment that converts different forms of energy to the useful form of energy we need, boilers, furnaces. We transfer that into our system. We control the amount of energy we provide. But the intent here, once again, is to have comfortable conditions for our occupants. And these conditions are quantified in terms of temperature, relative humidity, draft. So all these conditions that we are aiming for, and we are not going to look for energy usage reduction at the cost of reducing this level of comfort. Similarly, for cooling, we have same system here, ventilation, same idea. We have systems that distribute that to our spaces. And in the complexity of these HVAC systems, what we are looking for is where we see potential for improving energy efficiency, basically reducing the loss in those conversion processes. We are including in our design for the buildings heat recovery. There is a lot of energy that we exhaust from our space that we can recover and bring back, exhaust air, hot water, all those flows of energy out can be reduced, and energy can be used then back into the building. Demand control ventilation, that's another potential measure. We know that when we design our buildings, we design for the worst case scenario. And that means that most of the time the systems will operate at higher loads than they actually need. So demand control ventilation would be adjusting or modulating what we provide to the actual conditions in the space. and various other technologies that we listed here. And once again, you probably have seen them in your projects. They are somehow becoming mainstream nowadays in our buildings. Just as terms of references, I have in the slide here a number of different technologies, different energy conversion systems for both heating and cooling, and their associated efficiencies. Surprisingly, when we look at energy use in our buildings, we need to use the efficiency of a specific equipment in operation. It's not, the nominal efficiency that we get tested in a lab. And typically these are, the ranges of efficiency you see here, which come from RedScreen as well. As I mentioned, I find this to be a good source of information. And finally, I cannot skip discussing a bit about heat pumps, because it's such a fashionable project in many of our energy management initiatives nowadays. So typically we use heat pumps for two principal modes. We heat and we cool with the same type of equipment. And sometimes because of the conditions in heating mode, we need to have a kind of a third mode, I would say, which is the defrost cycle, to help the heat pump recover and then be able to continue to provide heating in our building here. So very popular nowadays is the air source heat pump, because technology was developed. We have better refrigerants, better compressors that can extract heat from the outdoor air, even in the middle of the winter. There are heat pumps that operate to -25 degrees Celsius. And if we are looking at a more stable source of heat as a resource for our heating systems, the ground would be a better source, but the cost will increase with the investment. We have to install that heat exchanger in the ground, and that's typically a more expensive type of installation compared with the air source heat pumps. This slide here, just for reference again, for those of you that haven't seen it yet, basically in heating and cooling mode, we reverse the way the vapor compression cycle operates. So the heat exchanger inside will deliver heat during the winter time, and the heat exchanger outside will exhaust heat during the cooling mode. So you can see this here, and this is done now very smart with changeover system valves, smart valves, and automatic controls for this equipment we have. Moving on to
just to sorry, before you move on, there was a question about using heat pumps in colder climates and -40. So a couple of things there. When it comes to a heat pump, I like to think about it. Don't think about it in degrees Celsius if you want to understand heat available in the air. Is think about it in degrees Kelvin. Degrees Kelvin, that's kind of how a heat pump operates. Even down to, you mentioned -40, there is a significant amount of heat in the air, so we still extract it. I would say also think about or check the temperatures and how cold the average temperature actually gets down. It's shocking. I mean, more in Southern Ontario, we don't necessarily get as cold as you think, but in more remote locations, they do to them. So depends on your system. You may need a backup system. Depends on how much budget you have to buy a system. You can size a full electric heat pump to cover off down to the cold temperatures in all climates here. Just depends on your budget as well. So a few things to consider when cold climate heat pumps in residential and commercial applications.
Excellent point, Adam, and thanks for raising up the question there. And I will come back to this in a little while for another slide where I would say we can optimize our resources. And in today's world, I think flexibility for our building systems would be a key element. I'll mention that when we talk about controls. And there is a lot more happening now in the building automation system. We have access to a lot more sophisticated automation, both hardware and software. We can modulate these systems that, keep in mind, were designed for the worst case scenario. but then operated at part load. And that's basically true as well with the heat pump. So if you want to use your heat pump in the dead of winter when the temperature is very, very cold outside, in most cases, you probably will find, in Ontario, you will find a heat pump to serve you completely, but you will have to size it quite large as a heat pump. So the controls will help us optimize this. And what I meant by, discussing the heat pump in the context of variable loads that we see in our building based on the season, is the cascade control system concept here. So what we basically want is to have the mix of resources that will optimize what we provide to the space in the most effective way. So not all equipment will operate the same efficiency. And if I use this heating application as an example, maybe for lower temperature, I can use just electric baseboards. If I move on to slightly higher temperatures, I can look at natural gas boiler as being the technology. And when I get into the warmer temperature, the heat pump will be the best option there to work. As I mentioned now, the range of heat pumps is expanding now. So we can actually cover a lot more with the heat pumps, the refrigerants, the compressor technology that the manufacturers build now for cold climates will allow you to extend the operation of the heat pump, but you'll end up with a very, very big device that will be operated for most of the year at part load. So maybe a hybrid system will make sense for the time being, given the still quick advances we see in the heat pump technology.
Dragos, we have another question here from David. He asked, I have asked designers what happens when a heat pump goes below its design temperature of -30, and they couldn't answer the question. Will the heat pump struggle, or will it actually shut down?
Most of these devices, David, will protect themselves, so they will shut down. Because now the refrigerant will not be able to complete the cycle. The heat pump operates on a concept of evaporating refrigerant at lower pressure, so you can change the temperature where the refrigerant evaporates by changing the pressure. And if you reach those temperatures that will not allow your refrigerant to evaporate, then you basically now pump liquid around. So the compressor will not work that way. So most of these devices will shut down.
If you're going to go below that, in a system that doesn't have backup source, you can either have electric or a fossil fuel backup to kind of make up for that in that situation. So hopefully it's been designed properly, where if you go below that design temperature, you don't ever actually shut down. So proper design is key.
And yes, Connor, I think that's a smart idea to use the base load with heat pumps, because that gives you the high number of hours. You optimize how you use the capacity you pay for, and then for peak, use some form of secondary technology. So that's what I meant by the hybrid solution. That economically may be the easiest to go. And that backup can, as Adam mentioned, could be even baseboard electric heaters.
Yeah, just Dragos. I'll point out here that Save On Energy does have some tools on their website to kind of explore the options between the full heat pump and the hybrid system, depending on your goals with decarbonization and cost. So maybe Megan or Priyasant can post a link to some of those kind of decarbonization tools we did a few years ago.
Yeah, true. Okay. And as Megan mentioned in the chat box, yes, some of these systems already have embedded a backup, the electric resistance, to help the heat pump operate when the temperature is really, really low. And moving on to basically kind of transitioning towards the new trends, and I'll pass it over to Adam at that point. Recommissioning, basically making sure that our buildings operate as intended, is very important. We are familiar with various programs that tie into the energy management framework for our buildings. We are looking at how best to use our building systems, what we already have in improving both the conditions or comfort for occupants as well as improving efficiencies. So new trends that we see in enhanced building commissioning for our systems. We see AI now as being part of various building sequences, control sequences. We work with building operators to implement recommissioning or commissioning as part of regular operations and try to improve the performance. We see basically various tools out there monitoring for fault detection and diagnostic embedded into building automation. So basically in the operation, energy optimization. I mentioned, complex chilled water plants that know when to push the cooling tower more or when to push the chiller more because they operate as a system. So some of these measures, implemented in our building system through the building automation system as kind of a continuous commissioning system. There are challenges in this field, and you can see some of these here using standardized approaches. And there are initiatives out there. ASHRAE has a number of standards that try to address operational improvements. There is a cost related to the information we need to collect, the gathering of these measurements, sensors that need to be calibrated. Otherwise, we rely on incorrect readings. Implementing some of these models may not be embedded by default in the building automation system. So, additional cost, sometimes significant cost may need to be added to the project. And, if we try pilots, moving from a pilot to full-scale implementation of these procedures to the entire portfolio may prove challenging as well. With that being said, I'll pass it over to Adam for emerging technologies.
Yep. Thank you, Dragos. And I've slightly modified the slide here this morning. I'm going to talk more about technologies and trends. Some of the times, it's not everything is technology. Sometimes it's just trends and what we're doing, data analysis, things like that. So I kind of included some of those in here. And it is by no means, we're only going to scratch the surface on some of the emerging technologies and trends. While I'm presenting here, if you have something you are doing in your organization that you think is kind of leading edge, feel free to type that in the chat. We can discuss that as well. This is just a few of my ideas on how things are going and where they're going. So again, not an extensive list, so feel free to add on to it again. And kind of before I jump into this, I want to summarize kind of what Drago said, is that basically what we want to do, how I see it, is we want to control what we can control in our building. So use as little as possible. Then the effects of kind of what's going on around you when it comes to climate, grid mix, things like that, demand response, all that kind of, we have that controlled. We limit the effects of the outside influence on us. So basically in Ontario here, we could just come into our buildings and we could throw a heat pump in, and that's going to reduce our carbon emissions, our GHG emissions by a lot. We may use a little bit of less energy depending on the situation, but we can jump in, we can decarbonize fairly quickly with just a heat pump. But if we don't address the other things like eliminating waste and optimizing efficiency, we are basically just wasting a little bit more efficiently in that case. So my goal with all of this is that to do all of the stuff Dragos talked about first, so we minimize the need for some of these emerging trends and technologies. A lot of cutting edge, leading edge things are more expensive. So if we don't need to spend as much money up front, that's better for us in the end. There was an example, again, my father, who's on here as well, who has doing this for a lot longer than I have. He has a story about a school board in Eastern Ontario here, where one of the building operators, he was talking one day how he went from an oil furnace to an electric baseboard heating, back to natural gas furnace, and then back to a heat pump recently. When at the end of the day, he probably should have just fixed the windows in his building. So it's, as David mentioned about windows and Dragos, that's eliminating the waste. It's very important in these buildings. So here, so what could the future look like? Without getting into too much detail in this graph, we've kind of discussed, or maybe you're more familiar with the industrial electrification, energy efficiency. I wanted to point out a couple of things here with the low carbon fuels. So on the y-axis there, there's some the LCF is low carbon fuels, and then carbon capture technologies in here. So that's kind of the more leading edge technologies that you may not have come across or kind of not used as widely in here. This whole graph, though, without getting into too much detail, it's kind of, again, brings in that holistic approach: reduce waste, maximize efficiency, and then go to the more expensive leading edge technologies there. So carbon capture and utilization, it's basically, there's lots of different ways to do it. I'm not going to get into the technicalities of all of them. There is organizations in Ontario using it. There's an organization, I found a LinkedIn post. We've done some work with them. They're kind of piloting a project in one of their buildings here. They're using an algae bubbler to remove whatever remaining CO2 is being put out from their building. So if you want to look a little bit more into that, I would suggest going and looking up the link in there in the building. There's also the federal government. There's lots of information about how we're capturing carbon in Canada right now. So moving on, and low carbon fuels, feedstocks, and energy sources. So this is kind of a bit higher level than maybe the Ontario context here. So there is lots of hydrogen exploration going on in Canada right now, as well as biogases, things like that. On top of that, I didn't put it in here, but there is lots of emerging technology when it comes to feedstocks. So feeding animals various different things to reduce the amount of greenhouse gases that maybe a livestock farm is emitting from them. So I know using things like seaweed is actually an emerging technology in feeding cows to reduce the amount of methane gas they emit in farming. So the next kind of context I want to frame energy efficiency kind of trends and technologies is framing energy efficiency as an investment. Many of you may be familiar with it. Even on a strictly on a lighting retrofit basis, some of the returns on investment on some of these energy projects are far greater than any of the investments you may have in your investment portfolio. So I would explore that. But also, there's actually a very good article written by Ali Haas, so I know he does a lot of work with the ISO as well. This Forbes article is climate proofing your property with sustainable upgrades transcends environmental responsibility, representing a strategic economic choice that can increase asset value, reduce operational costs, and ensure adherence to evolving technology. So basically what he's saying is that efficiency equals reliability and resilience, which equals value. So on top of spending less money, your property is now worth more in the future and resists those changes that are always happening in our world nowadays. So not even nowadays, it's always been happening. So again, control what you can control, increases the value of your property or your building over time. So.
And when you talk about the investments, Adam, Nick had a great comment there. Aside from incentives, we also have now various tax credits that are related to projects. So that's good to keep that in mind when you have this approach, looking at energy efficiency as an investment.
Yeah, great. Let's go. Okay, and then, so next thing I'm going to bring up, I put this in there only because I've been seeing a lot of things in the news lately about buildings and maintenance in buildings. I actually had a school board where I live here in Waterloo. They had a report that over 50% of their buildings were kind of in a state of disrepair. And oftentimes when maintenance is neglected, it directly is linked to energy. So this may not be kind of an emerging technology, but is very important in the future. Always is maintenance. This example here is not a school board. This is actually in my house here. So with my furnace here, when I had the clean filter is on the left here. We monitored it. It was running at 111 watts. And then a dirty filter was running at up to 353 watts. And this is with a high efficiency multi-stage fan. So it's going to work harder to actually get the airflow that is required in the building. So if you have a single stage fan, it's not necessarily going to cost you more energy in the terms of the demand, but the fan will just have to run longer to push more air through that dirty filter. So the effects will be the same depending on your situation. In this situation, we did a little bit of math at 240 watts or 0.24 kilowatts for another 2 weeks at about 16 cents a kilowatt hour on average. That's just over $13 in energy cost. You've basically bought if you buy these aren't even the expensive filters in this picture. You've bought multiple filters. I think there are three or four of them are about 10 to 20 bucks. So you basically bought those filters within 2 weeks if you don't replace it. So maintenance is still very important in your buildings for the future and forever, basically, is what so where is energy efficiency going? So intelligent AI filters, someone made a comment about that. I have not. Yeah, there's not even, back to rewind a bit on that, there's even filters you can buy that have a whistle in them. It's not AI, but it will whistle when you insert it in your filter. So when it's dirty, it forces more air through there instead of through the actual filter. So then it can actually do that. Yeah, I'm going to mention AI here briefly, but again, I am no expert in AI, and it's a very emerging technology. I will just point out a couple cautions I have on AI, I think. So the future. So we need to rethinking the role of energy efficiency, the need to scale energy efficiency faster and further, the need to diversify our sources of energy efficiency, measuring and ensuring persistence of energy savings, alignment of the energy efficiency and carbon reduction agenda, and in utilizing energy efficiency as a power system resource in the context of small-scale variable renewables. And the thing I want to point out there is this measuring and ensuring persistence of energy savings. I think another key, again, you've probably heard this many times, is measure and ensure savings. You need data. Good data is key in 2025 and beyond. I know there's lots of data out there. There's lots of, even without buying new meters in your building, there's lots of data you can pull out. What's available now. There's even with monthly data or your interval data, you can do a lot of analysis there. So getting good, clean data, analyzing, understanding where it's going in your building is the first step to anything you're going to go beyond that. Any of that, reduce waste, optimize efficiency, AI, you want to make sure you analyze your data, understand where it's going in your building, and then move on to the next step. So kind of role of AI, there's lots of different AI technologies. There's a product here called Hang to help you control your HVAC system. I won't get into the details of this. I just want to point out one thing before, and then I'll get to David's question right now, and then I'll go to the next slide to point out kind of a caution when it comes to using technology or AI-based things. So go ahead, David.
Yeah, I just wanted to have the IESO maybe comment on the green button. We were counting on green button to give us that data. And so I think there's a number of challenges, and even importing it into RedScreen as I'm sitting here with 24 months of bills for a building. So maybe you can just count, where do we get that data and how do we get it easily?
There's multiple different sources. I'd say in terms of the technicalities of green button, I'd say I'm not an expert on that. I know I have had challenges getting debug. I totally agree with you on the challenges of green button data. I think part of the challenge there is with all the number of utilities across Ontario. So getting permissions and how they export their data has been a bit of a challenge. But I would say there's monthly data. You can pull a lot of information out. If you want interval data, there is the ability to download the green button data. I'd say every utility I've worked with, it is usable. Sometimes it requires a bit of manicuring to get into a state where you can use it, but it is usable in some way, shape, or form. But also there's lots of relatively affordable sub-meters out there as well if you need to go even beyond that. So, but yeah, I'd say I can't answer officially on the green button data or the state of it. I'd have to take that back to the IESO directly. But yeah, it has been a bit of a challenge for sure.
No, thanks. And also with AI, I think there's a question about if you do AI and it does improve performance, does the IESO recognize that under their incentive program?
That question I will have to take back to the IESO directly. I'm not sure. I can't answer that one unless Dragos or Megan maybe or Pearson can answer that. But
I think we are so early on in implementing that in our buildings that we don't know yet what's happening with the projects. But just based on some of the projects implemented recently with other type of technologies, I think the amount of energy used to implement, let's say, a fault monitoring system in our buildings that will trigger a call for maintenance and avoid that filter to operate at high pressure drop longer than is needed. The amount of energy used for the actual fault monitoring system would be significantly less than the amount of energy that Adam showed you save. I don't think we have that yet quantified. I saw Natalie's comment there. And yes, at society level, I think we should be concerned with the amount of energy we use for AI. But when you compare with the benefit in our buildings, I don't see that to be a very high component.
Yeah.
It's just a qualitative comment at this point in time.
Yeah, so this AI technology, it is going to be a thing. It is hopefully going to be useful. But my one caution on that is to kind of explore what really creates the savings. This was a case study done in the UK where we used, I'm going to use technology as the AI. The numbers here are not necessarily tied to AI, but people and technology combined together are going to create the greatest savings in your buildings, and they're actually potentially greater than the sum of the two individually. So people only, as Dragos mentioned, like behavioral change is massive in a building. It's in my opinion, and arguably I'd say it's as big, if not bigger, than technology. Technology is not insignificant. We do have lots of great technology out there to do that. But and then technology alone, it potentially can actually cost you energy if you don't monitor it. I think at this point in the AI and things like that, it still requires human input to kind of monitor and make sure it's still on track there. So just be cautious with it. We're in the early phases of that. That's all I'm going to say on AI there. So that's all I had presented on the kind of the emerging trends in energy efficiency and decarbonization. I think someone pointed out the other thing I was thinking about as we were talking there is to look at the whole picture with AI and kind of the emissions or the GHGs that are generated on the AI side as well as in your building. So I think there needs to be a lot more studies done on what the balance is and if it is a net benefit. Okay. So.
Thank you, Adam, for that. Before you wrap up the presentation, we do have another quick poll right now. So just 1 second here. Everyone should be able to see the poll question just in a bit. Okay. And if you are not able to see it, I'll drop in the link and the code to access the poll online. So the question we have today is, were there any surprising insights you're taking away from today's presentation? So again, feel free to respond, and all the responses are going to be anonymous. Is everyone able to see the Mentimeter yet? Okay. Operation of the heat pumps in cold weather, none. Air filter, inefficiency and added cost. Let's see if we can help you with that in the future. Heat control, air possibilities and heat pump behaviors. So we're seeing a lot of heat pumps and AI comments here. That's good to hear. Okay, and let's move on to the next questions because we're closing in on the time. Next question is, which of the following actions do you think you'll take on next? So either implement an energy awareness campaign, start scoping a new project to save energy, research a new technology, or reach out to the Save on Energy platform for support. Okay. So we have a lot of reach out to Save on Energy and research new technology. Okay. And in the meantime, if you do have any other questions, feel free to raise your hand right now, ask upon, and in the comments as well. I think David has another question. David, do you have a question right now? Or is that from before?
Well, I'm just going to mention ASHRAE is having a meeting April 10th, and it's about indoor air quality. And I think it goes to the issues that Dragos mentioned. We have to keep people safe, but we also have to keep the issues of COVID and flu and RSI. And so there's a big debate about ventilation versus filtration that ASHRAE is holding. And there is a new standard 241 from ASHRAE that has testing capabilities that will see if you're overventilating.
Very good comment. Thanks for mentioning that, David. So just to kind of wrap up our presentation here, we think that we summarize these three ideas. We would like to get efficiency to be considered before generation, conservation before generation. We also think that AI impact on building systems, energy efficiency building system is going to be quite significant. So we need to kind of prepare ourselves. We see that interest in that as well. And lastly, but not the least important, stakeholders are just very important, as Adam showed, even more important than the technology in our buildings. So we need to have that energy awareness plan or energy efficiency awareness plan developed for our organizations. So we are right on time here. I think we will still open the floor for a few questions. If anyone still has a question in mind that wasn't addressed yet. But in the meantime, I'll leave this last slide showing some links that may be useful. And I believe Megan also listed a few of these in the chat box for you to save for further information.
Yeah, so feel free to go onto our social media, to our Twitter, Facebook, and LinkedIn accounts, and follow right there for any future updates. And if you want any of the materials, fact sheets, and guides, or past webinar sessions, just go into the Save On Energy website and go under Training and Support, and you'll see all of our previous materials as well. And if you sign up for the Save On Energy quarterly business newsletters, you'll get more updates as well. So again, we open the platform for
website.
Go ahead, David.
You'll be posting these slides on the website?
Yeah, we'll be posting them later this week.
Thanks.
So again, just feel free to respond. Engage in questions, raise your hand, or just in the chat as well.
Thanks for participating, folks, and really appreciate feedback. It says we discussed at the beginning quite a lot of expertise in the group, and we were happy to be with you for this event.
And thank you, Adam and Dragos, for that very insightful presentation. Yeah, thank you for coming.